In this video, we are introducing nearest neighbor introduction. So for both classification and regression predictive problems, we can use these nearest neighbor algorithms, also known as KNN. So actually what is happening in case of KNN, in our pattern recognition, the K nearest neighbor algorithm, that is also in abbreviated form is known as KNN, is a non-parametric method used for classification and also for regression. In both cases, the input consists of k number of closest training examples in the feature space, and the output depends whether KNN is used for classification or for regression. Now question is coming in mind that why we should develop this respective algorithm. So now what is happening that to evaluate any technique, we generally look for three main important aspects. The first one is the ease to interpret output. The second one is the calculation time, and the third one is the predictive power. That means how much it can do the accurate and the most probable predictions. So let us take a few examples to place KNN in the respective scale. So here we have taken logistic regression, we have taken CART, that is the classification and regression trees, we have taken random forest and also KNN. So if you consider this easy to interpret output, you have found that how the scoring has been made for calculation time and for predictive power. So KNN algorithm fares across all the parameters and under the consideration, and it is commonly used for its ease to interpretation and low calculation time. In KNN classification, the output is a class membership. An object is classified by plurality vote of its neighbors, and with the object being assigned to the class most common among its k nearest neighbors, and where is a k is a positive integer, actually typically a small positive integer, and if k is equal to 1, then the object is simply assigned to the class of the single nearest neighbor. And if KNN regression, in case of KNN regression, the output is the property value of the object. This value is the average of the values of the k nearest neighbors. So just consider this respective diagram. Here we are having this one as the data point. So this one are the data points, and here we are having for k is equal to 1, for one nearest neighbor we will be having only one class here. You can find that we are having two classes here. One is a plus, another one has been denoted by minus. So in this particular case, in case of two nearest neighbor, for this particular data point I have found two neighbors, one from minus and another from plus class. And in case of three nearest neighbor, I've taken this particular data point and three neighbors are there. So here you can find that the voting is more for the plus class, so we can predict that this particular data point will have the predicted class as plus. The KNN is a type of instance-based learning, or also known as lazy learning, where the function is only approximated locally and all computation is deferred until the classification. Both the classification and regression, a useful technique can be to assign weights to the contributions and of the neighbors, so that the nearer neighbors contribute more to the average than the more distant one. For example, a common weighting scheme, it consists in giving each neighbor a weight of say 1 by d, where d is known as the distance to the neighbor. So just consider this one. We are having the training method, that is the save the training examples. At the prediction time, find the k training examples, and where we are having x1 y1 comma x2 y2 comma dot 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 at xk yk, that are the nearest to the test example x. Predict the most frequent class among those yi's, and improvements will be there, that weighting examples from the neighborhood and measuring closeness and finding close examples in a large training set quickly. The neighbors are often from a set of objects for which the class, that means for the KNN classification, or the object property value, that means for KNN regression, is known, and this can be thought of as training set for the algorithm, though no explicit training step is actually required. In peculiarity of the KNN algorithm is that it is sensitive to the local structure of the data. That means the neighbors will influence more in the decision making process. Thanks for watching this video.